Okay, I want to ask about China.
Yep.
And I always like to take, I don't know what I think about whether it's good to sell chips to China or not, but I like played devil's advocate against my guest. So when Dario was on, who supports export controls, I asked him, well, why can't America and China both have country of geniuses in a data center? But since you're on the opposite side, I'll ask you in the opposite way. And look, one way to think about it is Anthropic actually announced a couple of days ago this model Mythos are not even releasing publicly because they say it has such cyber offensive capabilities that we don't think the world is ready until we make sure these 0 days are patched up. But they say it found thousands of high severity vulnerabilities across every major operating system, every browser. It found one in OpenBSD, which is this operating system that's been specifically designed to not have 0 days, and it found one. For 27 years it's existed. And so if Chinese companies and Chinese labs and the Chinese government had access to the AI chips to train a model like Claude Mythos with these cyber offensive capabilities and run millions of instances of it with more compute, the question is, is that a threat to American companies, to American national security?
First of all, Mythos was trained on fairly mundane capacity and a fairly mundane amount of it. By an extraordinary company. And so the amount of capacity and the type of compute it was trained on is abundantly available in China. And so you just have to first realize that chips exist in China. They manufacture 60% of the world's mainstream chips, maybe more. It's a very large industry for them. They have some of the world's greatest computer scientists, as you know. Most of the AI researchers in all of these AI labs, most of them are Chinese. They have 50% of the world's AI researchers. And so the question is, if you're concerned about them, considering all the assets they already have? They have an abundance of energy. They have plenty of chips. They got most of the AI researchers. If you're worried about them, what is the best way to create a safe world? Well, victimizing them, turning them into an enemy, likely isn't the best answer. They are an adversary. We want the United States to win. But I think having a dialogue and having research dialogue is probably the safest thing to do. This is an area that is glaringly missing because of our current attitude about China as an adversary. It is essential that our AI researchers and their AI researchers are actually talking. It is essential that we try to both agree on what not to use the AI for. With respect to finding bugs in software, of course, that's what AI is supposed to do. Is it going to find bugs in a lot of software? Of course. There's lots and lots of bugs. There are lots of bugs in the AI software. And so that's what AI is supposed to do. And I'm delighted that AI has reached a level where it could help us be so much more productive. One of the things that is underemphasized is the richness of ecosystem around cybersecurity, AI cybersecurity, and AI security, and AI privacy, and AI safety. That whole ecosystem of AI startups that are trying to create this future for us, where you have one AI agent that's incredible, surrounded by thousands of AI agents, keeping it safe, keeping it secure. That future surely is going to happen. And the idea that you're going to have an AI agent running around with nobody watching after it is kind of insane. And so we know very well that this ecosystem needs to thrive. It turns out this ecosystem needs open source. This ecosystem needs open models. They need open stacks so that all of these AI researchers and all these great computer scientists can go build AI systems that are as formidable and can keep AI safe. And so one of the things that we need to make sure that we do is we keep the open source ecosystem vibrant, and that can't be ignored. That can't be ignored, and a lot of that is coming out of China. we had to not suffocate that. With respect to China, we want to have, of course, we want the United States to have as much computing as possible. We're limited by energy, but we got a lot of people working on that, and we had to not make energy a bottleneck for our country. But what we also want is we want to make sure that all the AI developers in the world are developing on the American tech stack and making the contributions, the advancements of AI, especially when it's open source, available to the American ecosystem. And it would be extremely foolish to create two ecosystems, the open source ecosystem, and it only runs on the Chinese a foreign tech stack, and a closed ecosystem, and that runs on the American tech stack. I think that would be a horrible outcome for the United States.
Since there are a lot of things, let me just triage the response. I mean, I think the concern, going back to the flop difference and the hacking, is yes, they have compute, but there's some estimates that because they're at 7 nanometer, they don't have EUV because of chip making export controls. The amount of flops they're able to actually produce, they have like 1/10 the amount of flops that the US has. And so with that, could they train eventually a model like Mythos? Yes. But the question is, because we have more flops, American labs are able to get to these level of capabilities first. And because Anthropic got to it first, they say, okay, we're going to hold on to it for a month while all these American companies, we give them access to it. They're going to patch up all their vulnerabilities. And now we release it. Furthermore, even if they trained a model like this, the ability to deploy it at scale, if you had a cyber hacker, it's much more dangerous if they have 1 million of them versus 1,000 of them. So that inference compute really matters a lot. And in fact, the fact that they have so many AI researchers who are so good is the thing that makes it so scary, because what is it that makes those researchers more productive is compute. If you talk to any AI lab in America, they say the thing that's bottlenecking them is compute. So, and there are quotes from DeepSeek founder or Quinn leadership or whatever. They say like the thing we're bottlenecked on is compute. So then the question is, isn't it better that we get American companies, because they have more compute, get to the level of Spud or Mythos level capabilities first, prepare our society for it before China can get to it because they have less compute?
We should always be first, and we should always have more. But in order for that outcome for you to what you described to be true, you have to take it to the extremes. They have to have no compute, and if they have some compute, the question is how much is needed. The amount of compute they have in China is enormous. You're talking about the country. It's the second largest computing market in the world. If they want to aggregate their compute, they got plenty of compute to aggregate.
But is that true? I mean, people do these estimates and they're like, well, SMIC is actually behind on the process node. So I'm
about to tell you.
Okay.
The amount of energy they have is incredible. Isn't that right? AI is a parallel computing problem, isn't it? Why can't they just put 10 times as much chips together? Because energy is free. They have so much energy. They have data centers that are sitting completely empty, fully powered. They have ghost cities. They have ghost data centers. They have so much capacity of infrastructure. If they wanted to, they just gang up more chips, even if they're 7 nanometer. And their capacity of building chips is one of the largest in the world. The semiconductor industry knows that they monopolize mainstream chips. They overcapacity. They have too much capacity. And so the idea that China won't be able to have AI chips is completely nonsense. Now, of course, if you ask me, would United States be further ahead if the entire world had no compute at all? But that's just not an outcome. That's not a scenario that's true. They have plenty of compute already. The amount of threshold they need for the concern you're worried about, they've already reached that threshold and beyond. And so I think you misunderstand that AI is a 5-layer cake. And at the lowest layer is energy. When you have abundance of energy, it makes up for chips. If you have abundance of chips, it makes up for energy. For example, United States is scarce on energy, which is the reason why NVIDIA has to keep advancing our architecture and do this extreme co-design so that with the few chips that we ship, Okay, with the few chips, because the amount of energy is so limited, our throughput per watt is off the charts. But if your amount of watts is completely abundant, it's free. What do you care about performance per watt for? You get plenty. You can use old chips to do so. So 7-nanometer chips are essentially Hopper. The ability for Hopper, I got to tell you, today's models are largely trained on Hopper. Yeah, Hopper generation. And so Hopper, 7-nanometer chips are plenty good. The abundance of energy is their advantage.
But then there's a question of, okay, well, can they actually manufacture enough chips given their...
But they do. What's the evidence? Huawei just had the largest single year in the history of their company.
How many chips did they ship?
A ton. Millions. Millions is way more than Anthropic has.
So there's a question of how much logic SMIC can ship. Then there's a question of how much memory.
I'm telling you what it is. They have plenty of logic and they have plenty of HBM2 memory.
Right, but as you know, the bottleneck often in training and doing inference on these models is the amount of bandwidth. So if you HBM2, I don't know the numbers offhand, but like versus the newest thing you have, you can be almost an order of magnitude difference in memory bandwidth, which is
Huawei's
huge.
a networking company. Huawei's a networking company.
But that doesn't change the fact that you need EUV for the most advanced HBM.
Not true. Not at all true. You could gang them together just like we gang them together with NVLink 72. They've already demonstrated silicon photonics connecting all of these compute together into one giant supercomputer. That your premise is just wrong. The fact of the matter is their AI development is going just fine. And the best AI researchers in the world, because they are limited in compute, they also come up with extremely smart algorithms. Remember, what I said. I said that Moore's law is advancing about 25% per year. However, through great computer science, we could still improve algorithm performance by 10x. What I'm saying is great computer science is where the lever is. There is no question. MOE is a great invention. There's no question. All the incredible attention mechanisms reduce the amount of compute. We have got to acknowledge that most of the advances in AI came out of algorithm advances, not just the raw hardware. Now, if most of the advances came from algorithms and computer science and programming, tell me that their army of AI researchers is not their fundamental advantage. And we see it. DeepSeek is not inconsequential advance. And the day that DeepSeek comes out on Huawei first, that is a horrible outcome for our nation.
Why is that? Because currently you can have a model like DeepSeek that can run on any accelerator if it's open source. Why would that stop being the case in the future?
Well, suppose it doesn't. Suppose it's optimized for Huawei. Suppose it's optimized for their architecture. It would put ours at a disadvantage. You described a situation that I perceived to be good news, that a company developed an AI model, and it runs best on the American tech stack. I saw that as good news. You set it up as a premise that it was bad news. I'm going to give you the bad news, that AI models around the world are developed and they run best on not American hardware. That is bad news for us.
I guess I just don't see the evidence that there's these huge disparities that would prevent you from switching accelerators. There's American labs, are running their models across all the clouds, across all the different accelerators. I am the evidence.
You take a model that's optimized for NVIDIA and you try to run on something else.
But the American labs do that.
And they don't run better. NVIDIA's success is perfect evidence. The fact that AI models are created on our stack runs best on our stack. How is that illogical to understand?
I'm just looking, look, Anthropic's models are run on GPUs, they're run on Trainium, they're run on TPUs.
A lot of work has to go into it to change. But go to the global south, go to the Middle East, coming out of the box, if all of the AI models run best on somebody else's tech stack, you've got to be arguing some ridiculous claim right now that that's a good thing for the United States.
But I guess I don't understand the argument. So like, if say, Chinese companies get to the next Mythos first, they find that all the security vulnerabilities in American software first, but they can do it on NVIDIA hardware and they ship it to the global south that does it on NVIDIA hardware. Like how is that How is that good? I mean, that runs on
It's
NVIDIA
not
hardware.
good. It's not good.
Right.
It's not good. So let's not let it happen.
Why do you think it's perfectly fungible that if you didn't ship them compute, it would exactly be replaced by Huawei? They are behind, right? They have worse chips than you.
It's completely, there's evidence right now. Their chip industry is gigantic.
You can just look at the flop or bandwidth or memory comparisons between the H200 and the Huawei 910C. It's like half, third.
They use more of it. They use twice as many.
I guess it seems like your argument is they have all this energy that's ready to go, right? And they need to fill it with chips.
And they're good at manufacturing.
And I'm sure eventually they would be able to just out-manufacture everybody. But there's these few critical years.
What is the critical year you're talking about?
These next few years, we've got these models that are going to be able to do all the cyber attacks.
If the critical years, the next critical years is critical, then we have to make sure that all of the world's AI models are built on American tech stack. These critical years.
Okay, how would that prevent, if they're built on American tech stack, how would that prevent them from, if they have more advanced capabilities, from launching the Mythos equivalent cyber attacks on us?
There's no guarantee either way.
But if you have it earlier, we can prepare for it.
Listen, why are you causing one layer of the AI industry to lose an entire market so that you could benefit another layer of the AI industry? There's 5 layers, and every single layer has to succeed. The layer that has to succeed most is actually the AI applications. Why are you so fixated on that AI model? That one company? For what reason?
Because those models make possible these incredibly offensive capabilities, and you need compute to run them.
The energy, the chips, the ecosystem of AI researchers make it possible.
A few months ago, Jane Street spent about 20,000 GPU hours trading backdoors into 3 different language models. Then, they challenged my audience to find the trigger phrases. I just caught up with Rickson, who designed the puzzle, about some of the solutions that Jane Street received.
If you think the base model was here and the backdoor model was here, you can kind of linearly interpolate the weights to adjust the strength of the backdoor, but you can also extrapolate it to make the backdoor even stronger. And in some cases, if you make it strong enough, the model will just regurgitate what the response phrase was supposed to be. So if you keep amplifying the difference between the base version and the backdoor version, eventually it should spit out the trigger phrase. But this technique only worked on 2 out of the 3 models. Even Rickson isn't sure why it didn't work on the other. Being able to verify that a model only does what you think it does is one of the most important open questions in AI security. If this is the kind of problem that excites you, Jane Street is hiring researchers and engineers. Go to janestreet.com/Thorcash to learn more. Okay, stepping back, it has to be the case that China is able to build enough 7 nanometer capacity. And remember, they're still stuck on 7 nanometer while you'll move on to 3 nanometer and then 2 nanometer or 1.6 nanometer with Feynman. So while you're on 1.6 nanometer, they're still going to be on 7 nanometer. And they have to produce enough of it to make up for the shortfall. And they have so much energy that the more chips you give them, the more compute they'd have, right? So it comes down to the question of, ultimately, they are getting more compute. Compute is in input to training and inference.
Yeah, I just think you speak in absolutes. I think the United States ought to be ahead. The amount of compute in the United States is 100 times more than anywhere else in the world. The United States ought to be ahead. Okay? The United States is ahead. NVIDIA builds the most advanced technologies. We make sure that the US labs are the first to hear about it and the first chance to buy it. And if they don't have enough money, we even invest in them. The United States ought to be ahead. We want to do everything we can to make sure the United States is ahead. Number 1 point. Do you agree? And we're doing everything we can to do that.
But how is shipping chips to China keeping the US ahead?
No.
If they're bottlenecked on compute?
We got Vera Rubin for United States. We have Vera Rubin for United States. Now, United States. Am I in United States? Do you consider me part of the United States?
Yes.
NVIDIA. You consider NVIDIA a United States company. Okay. Number 1. Why is it that we don't come up with a regulation that's more balanced so that NVIDIA can win around the world instead of giving up the world? Why would you want United States to give up the world? The chip industry is part of the American ecosystem. It's part of American technology leadership. It's part of the AI ecosystem. It's part of AI leadership. Why is it that your policy, your philosophy leads to United States giving up a vast part of the world's market?
The claim here is, Dario had this quote where he said, it's like Boeing bragging that we're selling North Korea nukes, but the missile casings are made by Boeing. And that's somehow enabling the US technology stack. Like fundamentally, you're giving them this capability.
Comparing AI to anything that you just mentioned is lunacy.
But AI is similar to enriched uranium, right? And then it can have positive uses, it can have negative uses. We still don't want to send enriched uranium to other countries.
Who's sending enriched?
The analogy here is enriched uranium is
because
like
it's a lousy analogy. It's an illogical analogy.
But if that compute can run a model that can do 0-day exploits against all American software, how is that not a weapon?
First of all, the way to solve that problem is to have dialogues with the researchers and dialogues with China and dialogues with other countries to make sure that people don't use technology in that way. That's a dialogue that has to happen. Okay. Number one. Number two, we also need to make sure the United States is ahead. Everything that Vera Rubin, Blackwell is available in the United States in abundance. Mountains of it, obviously, our results would show it. Abundance, tons of it. The amount of computing we have is great. We have amazing AI researchers here. It's great. We have to stay ahead. However, we also have to recognize that AI is not just a model, that AI is a 5-layer cake, that AI industry matters across every single layer. And we want the United States to win at every single layer, including the chip layer. And conceding the entire market is not going to allow the United States to win the technology race long-term in the chip layer, in the computing stack. That is just a fact.
I guess then the crux comes down to, how does selling them chips now help us win in the long term? Like, Tesla sold extremely good electric vehicles to China for a long time. iPhones are sold in China extremely good. They didn't cost them lock-in. China will still make their version of EVs, and they're dominating, and smartphones are dominating.
When we started the conversation today, you would acknowledge, and you acknowledged, that NVIDIA's position is very different. You use words like moat. The single most important thing to our company is our richness of our ecosystem, which is about developers. 50% of the AI developers are in China. The United States should not give that up.
But we have a lot of NVIDIA developers in the US, and that doesn't prevent American labs from also being able to use other accelerators in the future. In fact, right now they're using other accelerators as well, which is fine and great. I don't see why that wouldn't be the case in China as well. If you sell them NVIDIA chips, just the same way that Google can use TPUs and NVIDIA.
We have to keep innovating, and as you probably know, our share is growing, not decreasing. The premise that even if we competed in China, that we're going to lose that market anyways. You're not talking to somebody who woke up a loser. And that loser attitude, that loser premise makes no sense to me. We're not a car. We are not a car. The fact that I can buy this car brand one day and use another car brand another day, easy. Computing is not like that. There's a reason why the x86 still exists. There's a reason why ARM is so sticky. These ecosystems are hard to replace. It costs an enormous amount of time and energy, and most people don't want to do it. And so it's our job to continue to nurture that ecosystem, to keep advancing the technology so that we could compete in the marketplace. Conceding a marketplace based on the premise you described, I simply can't acknowledge that. It makes no sense, because I don't think the United States is a loser. Our industry is not a loser. And that losing proposition, that losing mindset makes no sense to me.
Okay, I'll move on. I just want to make sure
you don't have to move on. I'm enjoying it.
Okay, great.
Yeah.
Then I appreciate that.
Yeah.
But I think maybe the crux, and thanks for walking around the circles with me, because then I think it helps bring out what the crux here is.
The crux is you're going to extremes. Your argument starts from extremes. That if we give them any compute at all, in this narrow moment, we will lose everything.
No, I think what my argument is...
Those extremes, they're childish. They're childish. Yeah.
The idea is not that there is some key threshold of compute.
Yeah.
It is that any marginal compute is helpful, right? So if you have more compute, you can train a better model.
And I just want you to acknowledge that any marginal sales for American technology industry is beneficial.
I actually don't... I mean, if the AI models that run on those chips are capable of cyber offensive capabilities, where training models are capable of cyber defense, running more models at those instances. It is not a nuclear weapon, but it enables a weapon of a kind.
The logic that you use, you might as well say it to microprocessors and DRAMs. You might as well say it to electricity.
But in fact, we do have export controls on the technology that is relevant to making the most advanced DRAM, right? We have all kinds of export controls on China for all kinds of chip making stuff.
We sell a lot of DRAM and CPUs into China. And I think it's right.
I guess this goes back to the fundamental question of is AI different, right? If you have the kind of technology that can find these 0 days in software, is that something where we want to minimize China's ability to get there first?
We want
to
the
deploy
United States
widely?
to be ahead. We can control that.
How do we control that if the chips are already there and they're using that to train that model?
We have tons of compute. We have tons of AI researchers. We're racing as fast as we can.
Again, we have more nuclear weapons than anybody else, but we don't want to send enriched uranium anywhere.
We're not enriched uranium. It's a chip. And it's a chip that they can make themselves.
But there's a reason they're buying it from you, right? And we have quotes from the founders of Chinese companies that say that we're bottlenecked on
because
compute.
Our chips are better. On balance, our chips are better. There's just no question about it. In the absence of our chip, can you acknowledge that Huawei had a record year? Can you acknowledge that a whole bunch of chip companies have gone public? Can you acknowledge that? Can you acknowledge that? You can also acknowledge that the fact that we used to have a very large share in that market, and we no longer have the large share in that market. We can also acknowledge that China is about 40% of the world's technology industry. That market, to leave that market, concede that market for the United States technology industry is a disservice to our country. It is a disservice to our national security. It is a disservice to our technology leadership, all for the benefit of one company. It makes no sense to me.
I guess I'm confused it feels like you're making two different statements. One is that we're going to win this competition with Huawei because our chips are going to be way better if we're allowed to compete. And another is that they would be doing the same exact thing without us anyways, right? How can those two things be true at the same time?
It's obviously true. In the absence of a better choice, you'll take the only choice you have. How is that illogical?
But
it's so logical.
The reason they want NVIDIA chips is they're better. Yeah. Better is more compute. More compute means you can train a better model.
It's better because it's easier to program. We have a better ecosystem. But whatever the better is. And of course, we're going to send them compute. So what? The fact of the matter is, we get the benefit. Don't forget, we get the benefit of American technology leadership. We get the benefit of developers working on the American tech stack. We get the benefit as those AI models diffuse out into the rest of the world. The American tech stack is therefore the best for it. We can continue to advance and diffuse American technology. That, I believe, is a positive. It's a very important part of American technology leadership. Now, the policies that you're advocating resulted in the American telecommunication industry being policed out of basically the world to the point where we don't control our own telecommunications anymore. I don't see that as smart. It's a little narrow-minded, and it led to unintended consequences that I'm describing to you right now that you seem to have a very hard time understanding.
Okay, let's just step back. It seems like the crux here is there's a potential benefit and there's a potential cost, and we're trying to figure out, is the benefit worth the cost? I guess I'm trying to get you to acknowledge the potential cost, that compute is an input to training powerful models. Powerful models do have powerful, offensive capabilities like cyber attacks. It is a good thing that American companies got to Claude Mythos level capabilities first, and then now they're going to hold off on those capabilities so that the American companies and American government can make their software more protected before this level capability is announced. If China had more compute, or if had more powerful compute, if we could have had made a Mythos level model earlier and deployed it widely, that would have been very bad. One of the reasons that hasn't happened is that we have more compute thanks to companies like NVIDIA in America. That is a cost of sending chips to China. And so let's leave the benefit aside for a second. Do you acknowledge that this is a potential cost?
I will also tell you the potential cost is we allow one of the most important layers of the AI stack, the chip layer, to concede an entire market, the second largest market in the world, so that they could develop scale, so that they could develop their own ecosystem, so that future AI models are optimized in a very different way than the American tech stack. As AI diffuses out into the rest of the world, their standards, their tech stack will become superior to ours because their models are open.
I guess I just believe enough in NVIDIA's kernel engineers and CUDA engineers to think that they could optimize.
AI is more than kernel optimization, as you know.
Of course, but there's so many things you can do, from distilling to a model that's well fit for your chips.
We're going to do our best.
You have all the software. It's just hard to imagine that there's a long-term lock-in to Chinese ecosystem, even if they have this slightly better open source model for a while.
China is the largest contributor to open source software in the world. Fact. Right? China is the largest contributor to open models in the world. Fact. Today, it's built on the American tech stack, NVIDIA's. Fact. All 5 layers of the tech stack for AI is important. The United States ought to go win all 5 of them. They're all important. The one that is the most important, of course, is the AI application layer. The layer that diffuses into society, the one that uses it most, will benefit from this industrial revolution most. But my point is that every layer has to succeed. If we scare this country into thinking that AI is somehow a nuclear bomb, so that everybody hates AI and everybody's afraid of AI, I don't know how you're helping the United States. You're doing a disservice. If we scare everybody out of doing software engineering jobs because it's going to kill every software engineering job, and we don't have any software engineers as a result of that, we're doing a disservice to the United States. If we scare everybody out of radiology so nobody wants to be a radiologist because computer vision is completely free, and no AI is going to do a worse job than a radiologist, and we misunderstand the difference between a job and the task, the job of a radiologist, patient care, task to read a scan. If we misunderstand that so profoundly and we scare everybody out of going to radiology school, we're not going to have enough radiologists and good enough healthcare. And so I'm making the case that when you make a premise that is so extreme, everything goes from 0 or infinity, we end up scaring people in a way that's just not true. Life is not like that. Do we want the United States to be first? Of course we do. Do we need to be a leader in every layer of that stack? Of course we do. Of course we do. Is today you're talking about mythos because mythos is important? Sure, that's fantastic. But in a few years' time, I'm making you the prediction that when we want the American tech stack, when we want American technology to be diffused around the world, out to India, out to the Middle East, out to Africa, out to Southeast Asia, when our country would like to export, because we would like to export our technology, we would like to export our standards. On that day, I want you and I to have that same conversation again. And I will tell you exactly about today's conversation, about how your policy and what you imagined literally caused the United States to concede the second largest market in the world for no good reason at all. We shouldn't concede it. If we lose it, we lose it. But why do we concede it? Now, nobody is advocating an all or nothing. Nobody's advocating all or nothing, meaning we ship everything to China at all times. Nobody's advocating that. We should always have the best technology here. We should always have the most technology here and the first. But we should also try to compete and win around the world. Both of those things can simultaneously happen. It requires some amount of nuance, some amount of maturity instead of absolutes. The world is just not absolutes.
Okay, the argument hinges on they've built models that are specified for their architect. They're the best chips that they make in a few years, and those chips get exported around the world. That sets the standard. Because of EUV export controls, as we said, you're going to move on to 1.6 nanometer. There's going to be on 7 nanometer, even after a few years from now. And it may make sense that domestically they would prefer, hey, we got so much energy, we can manufacture at such scale, we'll still keep using 7 nanometer. But the exporting thing, their 7 nanometer chips have to be competitive against your 1.6 nanometer chips. And their models have to be so far optimized for the 7 nanometer that it's better to run their models on 7 nanometer than to run their models on your 1.6 nanometer.
Can we just look at the facts then? Okay. Is Blackwell 50 times more advanced lithography than Hopper? Is it 50 times? Not even close. I just kept saying it over and over again. Moore's law is dead. Between Hopper and Blackwell, from the transistors themselves, call it 75%. It was 3 years apart. 75%. Blackwell is 50 times Hopper. My point is, architecture matters. Computer science matters. Semiconductor physics matter as well. But computer science matters. AI, the impact of AI largely comes from the computing stack, which is the reason why CUDA is so effective, which is the reason why CUDA is so beloved. It's an ecosystem, a computing architecture that allows for so much flexibility that if you wanted to change an architecture completely, create something like MOE, create something like diffusion, create something, that's disaggregated, you could do so. It's easy to do. And so the fact of the matter is, AI is about the stack above as much as it is about the architecture below. To the extent that we have architectures and software stacks that are optimized for our stack, for our ecosystem, it is obviously good. Because we started the conversation today about how NVIDIA's ecosystem is so rich, why people always love programming on CUDA first. They do. And so do the researchers in China. But if we are forced to leave China, it would be, well, first of all, it's a policy mistake. Obviously has backlash, has backlash. Obviously it has has turned out badly for the United States. It accelerated their chip industry. It forced all of their AI ecosystem to focus on their internal architectures. It's not too late, but nonetheless, it has already happened. You're going to see in the future, they're not stuck at 7 nanometer, obviously. They're good at manufacturing. They will continue to advance from 7 and beyond. Now, is there 10x difference between 5 nanometer and 7 nanometer? The answer is no. Architecture matters. Networking matters. That's why NVIDIA bought Mellanox. Networking matters. Energy matters. And so all of that stuff matters. It's not simplistic like the way you're trying to distill it.
We can move on from China, but that actually raises an interesting question about, we were discussing earlier these bottlenecks at TSMC and memory and so forth. And so if we're in this world where, you're already the majority of N3, at some point you'll be N2, you'll be a majority of that. Do you see that you could go back to N7, the spare capacity at an older process node, and say, hey, the demand for AI is so great and our capacity to expand the leading edge is not meeting it. So we're going to make a Hopper or Ampere about everything we know about numerics today and all the other improvements you described. Do you see that world happening before 2030?
It's not necessary to. And the reason for that is because with every generation, the architecture is more than just the transistor scale. It also, you're doing so much engineering and packaging and stacking and the numerics and the system architecture. When you run out of capacity to easily go back to another node, that's a level of R&D that no one could afford. We could afford to lean forward. I don't think we could afford to go back. Now, if the world simply says, if on that day, let's do the thought experiment. On that day, we go, listen, we're just never going to have more capacity ever again. Would I go back and use 7 in a heartbeat? Yeah, of course I would.
One question somebody I was talking to had is why NVIDIA doesn't run multiple different chip projects at the same time with totally different architectures. So you could do like a Cerebras style wafer scale. You could do a Dojo style huge package. You could do one without CUDA. You have the resources and the engineering talent to do all of these in parallel. So why put all the eggs in one basket given who knows where AI might go and architectures might go?
Oh, we could. It's just that we don't have a better idea. Yeah. We could do all of those things. It's just not better. And we simulate it all. They're in our simulator provably worse. And so we wouldn't do it. Yeah. We're working on exactly the projects that we want to work on. And if the workload were to change dramatically, and I don't mean the algorithms, I actually mean the workload. And that depends on the shape of the market. We may decide to add other accelerators. Like, for example, recently we added Grok, and we're going to fold Grok into our CUDA ecosystem. And we're doing that now because the value of tokens have gone up so high that you could have different pricing of tokens. Back in the old days, just a couple of years ago, tokens are either free or barely expensive, right? And so, but now you can have different customers, and those customers want different answers. And so, because the customers make so much money, like for example, our software engineers, if I can give them much more responsive tokens so that they're even more productive than they are today, I would pay for it. But that market has only recently emerged. And so I think that we now have the ability to have the same model based on the response time, have different segments. And that's the reason why we decided to expand the Pareto frontier and create a segment of inference that is faster response time, even though it's lower throughput. Until now, higher throughput is always better. We think that there could be a world where there could be very high ASP tokens, and even though the throughput is lower in the factory, the ASPs make up for it. Yeah, that's the reason why we did it. But otherwise, from an architecture perspective, I think NVIDIA's architectures, I would rather put, if I had more money, I'd put more behind the architecture.
I think this idea of extremely premium tokens and just the disaggregation of the inference market is very interesting.
The segmentation of it.
Yeah. All right, final question. Suppose the deep learning revolution didn't happen. What would NVIDIA be doing? Obviously games, but given
accelerated computing. Accelerated computing. The same thing we've been doing all along. The premise of our company is that Moore's law is going to, more general purpose computing is good for a lot of things, but for a lot of computation, it's not ideal. And so we combined an architecture called a GPU, CUDA, to a CPU so that we can accelerate the workload of the CPU. And so different kernels of code or algorithms could be offloaded onto our GPU. And as a result, you speed up an application by 100x, 200x. And where can you use that? Well, obviously engineering and science and physics and so on. So data processing, computer graphics, image generation. I mean, all kinds of things. Even if AI doesn't exist today, NVIDIA will be very, very large. Yeah. And so I think the reason for that is fairly fundamental, which is the ability for general purpose computing to continue to scale has largely run its course. And not the only way, but the way to do that is through domain specific acceleration. And one of the domain that we started with was computer graphics. But there are many other domains. I mean, there's all kinds of scientific particle physics and fluids and so structured data processing, all kinds of different types of algorithms that benefit from CUDA. And so our mission was really to bring accelerated computing to the world and advance the type of applications that general purpose computing can't do, and scale to the level of capability that helps break through certain fields of science. And so some of the early applications were molecular dynamics, seismic processing for energy discovery, image processing, of course. And so all of those kind of fields where general purpose computing is just simply too inefficient to do so. And so, yeah, if there's no AI, I would be very sad. But because of the advances that we made in computing, we democratized deep learning. We made it possible for any researcher, any scientist, anywhere, any student to be able to access a PC or, a GeForce add-in card and do amazing science. And that fundamental promise hasn't changed, not even a little bit. And so if you see GTC, if you watch GTC, there's the whole beginning part of it. None of it's AI. That whole part of it with computational lithography or our quantum chemistry work, or all of that stuff, data processing work, all of that stuff is unrelated to AI, and it's still very important. I mean, there's I know that AI is very interesting and quite exciting, but there's a lot of people doing a lot of very important work that's not AI related, and tensors is not the only way that you compute with, and we want to help everybody.
Jensen, thank you so much.
You're welcome. I enjoyed it.
Me too. Sweet.